Hi, welcome to Cool Gadgets and Stuff. From environmental pollution to climate change, man-made activities are threatening Earth's delicate ecosystems. In this video, we are going to take a look at some solutions being developed right now that could greatly help in the fight to preserve our environment. Global carbon dioxide emissions from fossil fuels are on track again to reach record highs in 2020. These heat-trapping gases are putting the world at risk for catastrophic climate change, and transitioning to green renewable energy has been slow. Just reducing emissions might not be enough. Some CO2 needs to be pulled out of the atmosphere as well. Carbon capture is the process of capturing waste carbon dioxide, usually from large point sources, such as cement factories or power plants, and depositing it in an underground geological formation where it forms a hard mineral. Climeworks, a company from Switzerland, has developed the first commercial carbon removal technology that captures CO2 emissions directly from ambient air. Their special module uses large fans to draw in ambient air, which is filtered through a specialized material that captures CO2 molecules. Each module can capture 50 tons of CO2 in a year. CO2-free air is then released back into the atmosphere. This continuous cycle is then ready to start again. This pure CO2 gas can then be sold to different industries, including food and beverage industries, agricultural, and the energy sector. CO2 can also be stored underground to create negative emissions and reduce CO2 content of the atmosphere. Carbon capture technology uses significant amounts of energy, so the real impact on achieving negative emissions might be modest unless green electricity is involved in the process. This technology is relatively new, and there isn't yet a proven market for emissions reversal. Although Climeworks claims its operating costs are decreasing, it has a long way to go before becoming commercially viable. The company already has its modules installed in a couple of locations in Europe, and their vision is to capture 1% of the global CO2 emissions by year 2025. Transitioning to green renewable energy sources is the priority in fighting pollution and climate change. Fusion, the nuclear reaction that powers the sun and the stars, is a potential source of safe, non-carbon emitting, and virtually limitless energy. In southern France, 35 nations are collaborating to build the world's largest fusion reactor that has been designed to prove the feasibility of fusion as a large-scale and carbon-free source of energy. ITER, or International Thermonuclear Experimental Reactor, is designed to test the technologies, materials, and physics necessary for the commercial production of fusion-based electricity. It will not capture the energy it produces as electricity, but will prepare the way for the machine that can. ITER will be the first fusion device to produce 10-fold surplus energy and maintain fusion for long periods of time. Thousands of engineers and scientists from all over the world have contributed to the design of ITER. In the south of France, construction has already been underway since 2010. The central reactor building is nearly completed and the reactor assembly is scheduled to start in 2020. The successful integration and assembly of over 10 million parts built around the world and delivered to the ITER site constitutes a tremendous logistical and engineering challenge. ITER's first plasma is scheduled for December 2025 and will be the first act of ITER's multi-decade operational program. ITER's planned successor DEMO is expected to be the first fusion reactor to produce electricity in an experimental environment. DEMO's anticipated success is then expected to pave the way for future commercialization and use of fusion power, possibly from 2050 onwards. The next technology has been around for a while. Gasification will transform common forestry or agricultural waste into gaseous fuel that can be used to run internal combustion engines, cooking stoves, or furnaces. It's a decades-old technology and was popular during World War II amid a gasoline shortage. Today, an alternative energy startup has slowly begun resurrecting this forgotten technology. All Power Labs, with their signature invention, a device called the Power Pellet, can generate clean and cheap burning fuel from nearly any dry organic matter for a fraction of what other green power sources cost. Power Pellet is a small refinery which converts biomass to hydrogen-rich gas, attached to a 4-cylinder engine which burns the gas to generate electricity. When done cleanly, gasification's only byproducts are exhaust and biochar, a nutrient-rich charcoal that can be used as plant fertilizer. And since all the carbon in plants originally came from the sky, the process is carbon negative. Carbon in plants, which would have been released in natural decomposition, is transformed into more stable biochar that goes back into the soil. Each growing season, more carbon can be sequestered from the atmosphere. Power pellets are mostly shipped to the developing world to fill the need for energy in places that lack appropriate grid infrastructure. Customers are drawn to the fact that the device can generate clean and cheap burning fuel from the waste agricultural material and replace diesel generators. And unlike solar panels, Power Pellet can run around the clock whenever it has plant waste to gasify. All Power Labs has been researching and developing in this forgotten field of gasification, and today employs over 35 people and has shipped over thousands of power pellets all over the world. They are also running local carbon networks that deliver biochar to community gardens to be used as fertilizer. The world plastic problem is out of control. Each day, many tons of plastic waste are deposited into rivers, oceans, and landfills, where they accumulate, causing problems for the wildlife and ecosystems. The Ocean Cleanup is a nonprofit organization that is developing advanced technologies to rid the world's oceans of plastic. Most plastic that enters the oceans comes from the rivers. In order to clean the world's most polluting rivers, they have built the Interceptor, an autonomous vessel that is designed to collect plastic from rivers before it reaches the oceans. Solar-powered interceptors are strategically located in the river. A partial barrier directs debris to flow to the mouth of the vessel, where the conveyor belt picks it out and distributes it into garbage containers. Once it's full, it sends a message to the operator on the shore, who then collects the containers and takes them back to the waste management facility. The Interceptor can extract up to 100 tons of trash each day. The Ocean Cleanup's aim is to tackle 1,000 of the world's most polluting rivers that contribute up to 80% of plastic dumped in the oceans. They are also working on reducing plastic already in the oceans. Most of the ocean plastic accumulates in 5 ocean garbage patches, getting caught in a vortex of circulating currents. If left to circulate, the plastic will increasingly impact the ocean's delicate ecosystems. So they have designed a system that could remove 50% of the Great Pacific Garbage Patch in just 5 years. The system consists of a long floater that sits at the surface of the water and a skirt that hangs beneath it. The floater provides buoyancy to the entire system, while the skirt prevents debris from escaping underneath and leads it into the retention system. Both the plastic and the system are being carried by the wind, waves, and current. However, to catch the plastic, there needs to be a difference in speed between the system and the plastics. Using a sea anchor to slow down the system, plastics can be retained and captured. This floating system is designed to capture plastics ranging from small pieces up to large debris. After years of trials, the Ocean Cleanup team just caught its first plastic in the Great Pacific Garbage Patch. This brings us to our next point: what to do with all the plastic in our environment. Plastic is difficult to recycle and it doesn't biodegrade. Most is burned or buried. The need to increase plastic recycling capacity is urgent. Scientists and businesses are already working on solutions, from biodegradable plastics to converting plastic into oil and petrol, to growing special bacteria that contains enzymes to digest plastic. But one company is converting plastic waste into construction material. Bifusion has created a solution to the plastic waste crisis. Biblock is the first construction-grade building material made entirely from recycled plastic waste. A machine dubbed the Blocker turns plastic debris into construction material. It shreds the plastic and then uses superheated water and compression to make the Biblocks. The Bifusion Blocker can convert any type of plastic waste into building materials, diverting it from landfills and the environment. Biblocks don't crack or crumble like concrete blocks, and only produce a fraction of the greenhouse gases in the manufacturing process. Biblocks are ideal for retaining walls, sheds, and non-load-bearing structures. The company is currently not focused on building entire houses with Biblocks. This next technology also has great potential. The Wave Roller is a device that converts ocean wave energy to electricity. The back and forth movement of water driven by a wave surge puts the wave roller panel into motion, which it converts into electricity by using hydraulic piston pumps that connect to a hydraulic motor that drives an electric generator. The electrical output from this wave energy power plant is then connected to the electric grid via a subsea cable. The machine operates in nearshore areas underwater at depths of approximately 8 to 20 meters or 25 to 65 feet, where the wave surge is most powerful. WaveRoller taps the unused ocean energy and provides a reliable and predictable source of clean and renewable energy. The hydraulic, mechanical, and electrical systems are also fully sealed inside the WaveRoller hull, which protects the marine life from noise and other possible pollutants. It can also generate far more energy than wind in a site of comparable size. A WaveRoller provides about 7 times more power generating capacity than a wind turbine in a similar sized area. The WaveRoller device operates underwater and has a very low visual impact, ensuring preservation of the natural beauty of the coastline. The first commercial-scale WaveRoller is already deployed on the coast of Portugal and has already begun feeding electricity to the Portuguese national grid. This is it for this video. Thanks for watching, and tell us in the comments what do you think about environmental technologies featured in this video and renewable energy in general. Bye for now, and stay tuned for more interesting videos.